Welcome back to another session on transportation problem. So, please stay with me for 6 to 7 minutes. It is very easy to understand transportation problem. Here you can see different variables like a factory and market. So there are 4 factories and 4 market. So we have to send, you know, the product, the unit from factory 1 to factory 3. The cost is for per unit, it is dollar 4, consider rupees 4. From factory 3 to market 4, then it is rupees 5. And you can see the capacity of each factory. Okay, 250, 300, 100, 200 respectively, and the demand of each market as well. So here in the linear programming, you can see the objective function, decision variable, and constraint. So the objective is to minimize the total transportation cost, and the decision variable here is like a quantity of material shipped from a factory 1 to market 2 or 3 or whatever it is, or different factory, or different factory to different market. So total decision variables are 4 factory into 4 markets is equal to 16. And the last thing to remember is constraint. That is total supply from factory is limited. That is only no the capacity of the factories are limited, and the total demand from market is also limited. If the factory produce more than the demand, that will also affect the factory. So here we have to find the minimal, the total total production. Okay, so that we'll find it, we'll write it later. So we have to copy this for doing the transportation problem. We have to copy and we have to just lift it down. Okay, and this column we have to cut and paste it here after one column, and here also demand we can take it, detach it from the existing to the next no column. Yeah, we can put it like next. So because we'll give some formulas to check the variables, and we can take off all the you know variables here. Okay, this is what exactly the constraint. Okay, the darker portion is constraint, so that you can I can differentiate it from other variables. So we can give the same equation which you have learned in assignment problem, that is sum total, that is sum of all the row, and you can drag it down. Here also you can do it same, is equal to sum of each column total. Okay, So it should be equal to the demand. So we have to check. That's why we have made this formula. So once the decision variables comes, definitely it should be tally with the demand as well as the capacity. So next is total cost. Total cost is equal to some product. This is an inevitable formula for linear programming. Some product of unit cost. You can see unit cost. Have an example. Unit cost is, if you want to, transport product from factory 2 to market 4, then it is like a 6. The unit cost is 6. If I have to transport, supply 10 units of a product from factory 2 to market 4, it is 6 into 10, that is 60 rupees. All right. So some product of unit cost into the quantity of material supplied, that which we are going to find out. Okay, so we done with the equations. Then go to data, take solver. So which is the objective? The objective is to find out the objective is to find out the total cost. So take the objective, take this cell, that is B21 as our objective, then minimize it, because since it is a transportation problem, we have to minimize the cost. And changing variable, what is changing variable? So we have to identify the changing variable. This is the changing variable. Okay, we call it as a decision variable also. Then add it. Then cell reference. So this is our one constraint. Okay, it should be less than or equal to, it should be less than or equal to this much of thing. Okay, add. Then take the next constraint, that is demand. It should be equal to, not shouldn't be less than or greater than. It should be equal to the market demand. Okay, then click OK. Then solve. If we are doing with Microsoft, like a Windows, if your operating software is MS Windows and Excel, definitely you have to go to the option and you have to change that option as assume linear model and assume non-negative. You can check it. You can see here, make unconstrained, something like that. A checkbox will be there once you click the option and go to the bottom, and you can see two checkbox. One is assume linear model and assume non-negative. So you have to check that and give solve. It will take time in my computer, so please be patient. Yes, so you can see all the constraints have been tallied with the capacity as well as the demand. You can see it is tally here, and you can see the factory 1 has to take 200 units to market 2 and 50 units to market 4, and factory 2 has to supply 90.59 units to market 1 and 200 units to market 2 and 9.4 units to market 4. Market factory 3 has to supply 100 units to market 4, and factory 4 has to supply 159.4 units to market 1 and 40.5 units to market 4. So here you can see the total cost, the minimal total cost, because if factory 1 is serving to market 1, then there is no demand. So the highest demand is with the for factory 1 is market 2 and market 4, same like respectively. So this is the total cost, optimal cost we can no identify, and we can send the product from different factory to different markets. Thank you.